friends, I welcome all of you to the YouTube channel of BYJU'S Exam Prep, formerly known as Grade Up. Now friends, BYJU'S Exam Prep is one of the most comprehensive app for all the examinations, including CAT and other MBA entrance examinations. Now here at BYJU'S, we prepare our students with end-to-end preparation, all right, so that they can achieve all their goals. I am Gourav Gupta and I once again welcome all of you to our next session in the series of algebra. Now friends, we have started this series of algebra. We have already seen 2 or 3 sessions before this one. We have seen a session on polynomials. We have seen a session on algebraic expressions. All right. Now here, I once again welcome all of you to our next session, which will deal with higher order equations in algebra. All right. Now, in this chapter, we'll look at basically how to find out how to basically deal with the sum and the product of roots. All right. Now, all of us will remember the properties of sum and product of the roots when it comes to quadratic equations. Now, if I talk about higher order equations above quadratic, so let's say 3-degree or 4-degree equations, then what all properties will be there which we can use in order to find out the sum, product and different things when comes to talking about the roots of the equation. All right, so let's talk about all these things in this session. Great. So I'll first of all take you through how to basically find out the roots of a quadratic equation which is in 2-degree. Okay, so we know that a quadratic equation can be termed as a 2-degree equation also. Okay, so quadratic equation or an equation having degree 2. So talking about the standard equation, of this type, just give me a minute. I think there is a problem with the reception. All right, so there is no problem, so we can go ahead. Okay, so talking about quadratic equation or a 2-degree equation, we can say that the standard form is mentioned in front of you, right? So standard form is ax square plus bx plus c. All right, now friends, if you're talking about the sum and product of the roots, so this is a standard quadratic equation, a standard 2-degree equation. Okay, so if I'll talk about the roots of this quadratic equation, so we may say that there will be 2 roots for this equation. Let me call these roots as alpha and beta. All right, let me call these roots as alpha and beta. Okay, now if I'll talk about the sum of the roots, that is alpha plus beta, then it will be equal to negative of b upon a. All right. If I talk about the product of the roots, then it will be c upon a. Am I clear? So sum of the roots will be minus b upon a and product of the roots will be c upon a. So basically, without actually calculating the roots of a given equation, we can comment upon the sum and the product of the roots. All right. Okay. Good evening, Krupa. Good evening, Payal. Sayam. Good evening. Welcome all of you. All right, it's good to see all of you here. Vanya, good evening. Okay, so till now, friends, we have just covered a standard 2-degree equation, that is ax square plus bx plus c. I'm talking about calculating sum of the roots and product of the roots without actually calculating the roots of the equation. All right, now taking an example for this, let's say the equation is 2x square plus 7x minus 3 equal to 0. Okay. Now the values of a, b and c, you have to be careful with the signs of a, b and c. Okay, so the value of a will be 2, the value of b will be 7 and the value of c will be minus 3. Now if I want to write alpha plus beta, that is sum of the roots, it will be minus b upon a. In this case, it will be minus 7 upon 2. Okay. Now c upon a is the product of the roots, that is alpha into beta. So c upon a, it will be minus 3 upon 2. Again, I am telling you to be careful with the signs of this equation. All right. Yes, Payal, you are absolutely right. Last day of CAT registration. So I request all of you, those who are still left, they haven't applied for CAT, please do that immediately. All right. Okay. So now this is the sum and the product of the roots. Okay. Now, if I look at these expressions of sum and product of the roots from the other angle, so in the first case, what I have done is, in the first case, I've taken the roots individually and calculated the sum of that. So I can refer it as sum of the roots taking one root at a time. All right. In the second case, you will understand it later. All right. So in the second case, what I've done is I've taken two roots at a time. So since this equation has only two roots, so I'll take both the roots together. So alpha into beta will calculate the product and it will be C upon A. Fine. Now you will understand what I'm trying to say by taking one root at a time, by taking two root at a time in the next case. So let's take an example of a 3-degree equation. Now, standard form of 3-degree equation, ax cubed plus bx squared plus cx plus d equal to 0. Now, this equation of 3-degree will have three roots. Let's say the roots are alpha, beta, and gamma. Okay. Now, the first thing, if I take one root at a time, that means I'll take these roots individually. So I'll take alpha, beta, and gamma individually and will calculate their sum. Okay. So sum taking one root at a time or sum taking individual roots. Now this value will be alpha plus beta plus gamma. In terms of A, B, C and D, you can calculate it by writing the value of minus B upon A. So alpha plus beta plus gamma, that is sum of the roots taking two roots at a time, it will be minus B upon A. Okay. Now the next thing is sum taking two roots at a time. So I have three roots, alpha, beta and gamma. I'll take the combination, I'll take all possible combinations of three roots. Sorry, I'll take all possible combinations of two roots. Okay, so the combinations will be alpha beta, then beta gamma, and gamma alpha. All right, and we'll put a positive sign between them. So that means this expression is for sum of the roots taking two roots at a time. All right. So alpha beta plus beta gamma plus gamma alpha, and the value will be equal to C upon A. That is sum of the roots taking two roots at a time. All right. Okay. Now next thing, taking all the three roots at a time. So if I take all the three roots, I have only three roots. So it will become the product of the roots. So product of the roots will be minus D upon A. Okay, so this is taking three roots at a time. Now, if you check it carefully, so sum of the roots, taking one root at a time, taking two roots at a time, taking three roots at a time, their values are minus B upon A, then C upon A, and then minus D upon A. All right. Now, in the denominator, always I have A. Okay, in the denominator, always A is there. In the numerator, starting from second coefficient, B, C and D. So B, C and D in the same sequence. Okay. Now talking about negative and positive sign. So starting with negative sign, I have alternate negative, positive, negative, positive and so on. So the first formula is minus B upon A. Then the second formula is plus C upon A. And the third formula is minus D upon A. Okay, now you will get to understand it in a much better way in the next case when I'll consider a 4-degree equation. Okay, fine. Yes, Chandan, I'll definitely take examples. So I'll go back, Monish, good evening. So I'll go back and will give you an example for this. All right. So let's say the 3-degree equation is 4x cubed minus 6x square plus 5x minus 3 equal to 0. Okay. Now the values of A, B, C and D. Let me write all these values. So the value of A is plus 4. The value of B is minus 6. value of C is plus 5 and the value of D is minus 3. Okay, so sum of the roots taking one root at a time is minus B upon A. So minus B upon A, that means minus of minus 6, which will be plus 6 divided by A, that is 6 upon 4, or you may write it as 3 upon 2. Then sum taking two roots at a time will be C upon A. Okay, now C is 5 and A is 4. Product of all the roots, or sum taking three roots at a time. Now sum taking all the roots at a time can be written as the product of roots also. ठीक है ना? So minus D upon A, so minus of minus 3, that will be plus 3 upon A, so it will be 3 upon 4. Okay, don't worry, I'll definitely take a proper question related to all these things. All right, so first of all, let us understand कि हम यहाँ पे कर क्या रहे हैं. Okay, so next example is 4-degree equation. So I'll generalize this rule later on. Fine. So standard form of 4-degree equation क्या हो जाएगा? It will be ax square plus bx cube plus cx square plus dx plus e equal to 0. Okay. Now there will be 4 roots in this case: alpha, beta, gamma and delta, let's say. Now sum taking one root at a time, that means alpha plus beta plus gamma plus delta, which will simply be the sum of the roots. It will be equal to minus b upon a. All right. Next, sum taking two roots at a time. Now if I'll make all the groups of two roots, so it will be alpha beta, alpha gamma, alpha delta, then beta gamma, beta delta, and finally gamma delta. So in all there will be 6 pairs taking two roots at a time. All right, so I'll write it like this. So sum of the roots taking two roots at a time will again be minus C upon A. Sum taking three roots at a time minus D upon A. And sum taking all the 4 roots, that means the product of the roots will be E upon A. All right. I hope I am clear to each and every one of you. Okay, so minus B upon A, C upon A, minus D upon A and E upon A. These are the expressions for sum taking one root at a time, two roots at a time, three roots at a time and 4 roots at a time. All right, now let's generalize this particular thing. If I have an n-degree equation, so the value of n can be anything. It can be 4, it can be 5, it can be 10, it can be 20 as well. So first of all, let's look at the standard form of an equation in n degree. Now, the highest power of x will be n. Okay, so the powers of x will keep on decreasing, and finally I'll not have any power of x. You can compare it with other equations that we have just seen. Okay, now as far as coefficients are concerned, I'm taking the coefficients as k1, k2, k3, k4 and so on. Now if I'll go back and look at a 4-degree equation. Now in 4-degree equation, number of variables were 1, 2, 3, 4, 5. Sorry, number of coefficients, number of constants were a, b, c, d and e. So there were 5 coefficients, there were 5 constants which were involved when the degree was 4. Okay, in the similar manner, if I am dealing with n-degree equation, then the number of coefficients or the number of constants will be equal to k plus 1. All right. Yes, Chandan, a will be in the denominator for all the roots. Okay, so now the coefficients are k1, k2, k3, k4, k5, kn and finally kn plus 1, the independent term. All right, so this is the standard n-degree equation. Okay, now this equation will have n roots obviously. Now the sum of roots taking one root at a time, that means sum of roots calculated individually. So how will I write it? So denominator in all these cases will be k1. So k1 will remain in the denominator for all these formulas. Okay, so I'll write all these formulas, I'll display all these formulas together. So taking one root at a time, taking two roots at a time, taking three roots at a time. You just check the denominators here. In all cases, the denominators are the first coefficient, okay, the first constant, that is k1. In the previous cases, it was a. In this case, it is k1. All right. Now taking one root at a time, in the numerator, it will be k2. Taking two roots at a time, k3. Taking three roots at a time, it will be k4, and so on. All right. So if I want to write taking four roots at a time, so it will be I'll not write plus or minus sign right now. So it will be k5 divided by k1. Okay. Now I have to decide whether it will be a positive or a negative sign. So can all of you please comment that will it be a positive or a negative sign? So I started with a negative, then positive, then negative, and now for this particular case, the sign will be positive. Okay, so it will be plus k5 upon k1. Taking 5 roots at a time, it will be k6 upon k1 and with a negative sign. All right. So taking n roots at a time, so if I'm taking 5 roots at a time, in the numerator, I'm writing the coefficient k6. So taking n roots at a time, the coefficient will be kn plus 1th divided by k1, and the negative positive sign will be decided by the value of n. So minus 1 raised to the power n will be the sign in this particular case. All right. Okay. So when I was taking one root at a time, the negative sign was minus 1 raised to the power 1. Okay. Taking one root at a time, it was minus 1 raised to the power 1, k2 upon k1. Okay. So if you will look at this particular thing in a general form, taking n roots at a time, it will be minus 1 raised to the power n. Yes, Vanya, alternate signs. So minus 1 raised to the power n and kn plus 1 divided by k1. Okay, fine. So Vanya, यहाँ पे हमेशा alternate negative and positive signs होंगे. Okay, so taking one root at a time, I'll write it again. So if you will use this formula in general, taking, let's say, 5 roots at a time, so the value of n will be 5. So minus 1 raised to the power 5 multiplied by kn plus 1, that means k6 divided by k1. In the denominator, k1 will remain there in all these cases. Okay, so this can be written as minus 1 raised to the power 5 will be a negative number, k6 divided by k1. Okay, so likewise you can make your own formula taking n roots at a time. All right. Okay, so this was something in general related to the roots of the equation. All right. Okay, अब कुछ questions देखते हैं. ठीक है. So equation is given to you, x cube plus 5x square minus 3x plus 2. All right, I'll be a little slow in this case. So first of all of you must be having a pen and a paper. So please write the values of a, b, c and d. Okay, meanwhile I'm doing this very slowly. All of you please write the values of a, b, c and d. ठीक है. So I'll do it very slowly in front of you. Now in this case, the value of a will be 1, the value of b will be 5, value of c will be minus 3, and the value of d will be 2. Okay. Now let's calculate things one by one. So first of all, since this equation will have 3 roots, so first of all, sum of the roots taking one root at a time. Again, quickly write your answer in your notebooks. No need to write it in the comment section. Okay. So sum of the roots will be minus b upon a. I'll write the values later on. I'm giving you time to do that. Then sum of the roots taking 2 roots at a time will be c upon a. And finally, the product of the roots will be minus d upon a. Okay. Now let me write all these values very quickly. So minus b upon a, that is minus 5 upon 1. C upon A will be minus 3 upon 1 and minus D upon A will be minus 2 upon 1. So sum of roots taking one root at a time will be minus 5. Taking two roots at a time will be minus 3. Taking three roots at a time will be minus 2. I hope all of you have written the same values in your notebooks. Okay, fine. Now let's move ahead and look at some higher level of difficulty questions in the similar case. Okay, so I'll use the same equation. Okay, and now we have to calculate the value of alpha square plus beta square plus gamma square. Okay, now if you have seen all my sessions, all my previous sessions, especially the last one, algebraic formulae, okay, then you will not have any difficulty in getting the answer for alpha square plus beta square plus gamma square. Now what we'll have to do is, in this case, I'll express this expression alpha square plus beta square plus gamma square in the form of either of these three. Okay, I'll repeat. I'll try to write alpha square plus beta square plus gamma square in the form of alpha plus gamma, or alpha beta, beta gamma, gamma alpha, or alpha beta gamma, because I can directly write the values of all three. So the values again I'll write minus 5, minus 3 and minus 2, which I'm going to use in next question. So let's do that. So one of the formulas that we have seen in my last session of algebraic expressions was alpha plus beta plus gamma whole square. Okay, a plus b plus c whole square. The formula will be alpha square plus beta square plus gamma square plus twice of alpha beta plus twice of beta gamma plus twice of gamma alpha. All right. Now here what we have to do is we have to find the value of the expression alpha square plus beta square plus gamma square. Now take it towards left hand side. Alpha square plus beta square plus gamma square. Leave it separately and take the remaining portion on the other side. So it can be written as alpha plus beta plus gamma whole square minus twice of alpha beta minus twice of beta gamma minus twice of gamma alpha. So I'll take 2 common, minus 2 common, and I'll write alpha beta plus beta gamma plus gamma alpha. Okay. Now to get the value of alpha square plus beta square plus gamma square, I've converted it in the form of alpha plus beta plus gamma, sum taking one root at a time, as well as sum taking two roots at a time. Now I'll take these values from the previous case. Okay, so alpha plus beta plus gamma ka value kya tha? It was minus 5. I'll substitute it here. So minus 5 whole square minus 2 bracket. What was sum taking two roots at a time? Its value was minus 3. Again, it will be substituted. So what will be the final answer? I hope all of you must have calculated the final answer. Vicky, Payal, Krupa, Gaurav, Monish. Come on, just quickly post your final answer, yaar. Please be ahead of me. So 25 plus 6, the final answer will be equal to 31. Right. So VM has posted the answer. So guys, as soon as you get the answer, please post it in the chat. Okay, don't write the process, just post your final answer and sit back and relax. Okay, so friends, this is how we calculate the value of alpha square plus beta square plus gamma square using the value of the expressions that we have calculated related to the roots of this equation. Okay, now let's take one more equation. Okay, so similar equation, same equation I believe. So value of alpha plus beta plus gamma, sum taking one root at a time. I'll write it as 1. Okay, so sum taking one root at a time, that is alpha plus beta plus gamma, will be minus 5. Sum taking two roots at a time, minus 3. And sum taking three roots at a time, that means the product of roots is minus 2. We have already calculated it earlier. Now some of you can take a lead and quickly solve this one and post your answer. Meanwhile, I'm solving this. Okay, meanwhile I'll solve this. So 1 upon alpha plus 1 upon beta plus 1 upon gamma. Let's take the LCM. So in the denominator, it will be alpha, beta, gamma. Taking LCM in the numerator, I'll have first of all beta gamma plus alpha gamma plus alpha beta. All right. So now in the numerator, I have sum of the roots taking two roots at a time. So I can write it as minus 3. And in the denominator, I have product of the roots or sum taking three roots at a time. So it will be minus 2. So final answer will be 3 upon 2 or 1.5 as written by Shivam, VM, Joydeep. Wonderful. All of you. Okay, great. Wonderful, Vicky. So all of you are absolutely correct. Fine. All right. Now let's move ahead and look at the next thing. So all of you again, just come back from whatever we have learned till now and let's talk about something different. Okay. Now in the remaining part of this lecture, I'll be talking about basically how to find out the nature of the roots of an equation. Now by nature, I mean to say that I'll be talking about the type of roots as far as real roots and complex roots are concerned, or positive or negative real roots are concerned. Fine. So you'll understand what basically I'm talking about. Now we can say that the number of roots of any equation, like whether it's a 2-degree equation, 3-degree equation, or a 4-degree equation. So the number of roots of any equation is always less than or equal to the degree of the equation. Okay. Now why I'm saying they can be less as well, because you have seen quadratic equations where both the roots are equal. Okay. So it may happen that some of the roots are equal. Okay, so I can say that the maximum number of roots will be equal to the degree of the equation. So if I'm dealing with a degree 3 equation, then the number of roots can be either 3 or less than 3. If I'm saying that the roots are less than 3, so obviously I mean to say that some of the roots are equal. Okay, so number of roots of the equation will be less than or equal to the degree of the equation. All right. So if we have a degree of equation as n, then the number of roots will be either less than or equal to n. Okay, considering the equal roots as well. All right. So now if I talk about the nature of these roots, like I have already mentioned earlier, so the roots can be real in nature or they may be complex numbers. All right. So roots can be either real or complex numbers. Now, if the roots are real, then I can say that they can be divided in two types of roots, either positive real roots or negative real roots. Now, this part will basically help you in estimating what will be the number of complex roots, what will be the number of positive real roots, or what will be the number of negative real roots. Okay, so just by looking at equation, we can have an idea about the number of complex, positive, or negative real roots. All right, so let's talk about this particular thing now. Now, first of all, talking about number of complex roots. Now, all the complex roots of any equation will occur in pair. Okay, so complex roots of any equation will always occur in pairs, as in one root will be complex conjugate of the other root. As in, if one of the roots is a plus iota b, then the other root will definitely be a minus iota b. All right, where iota is complex number. All right, iota is complex number, that is under root of minus 1. I'll repeat, the complex roots of any equation will always occur in pair, as in one root will be complex conjugate of the other root. So if one of the roots is a plus iota b, then automatically you can say that the other root has to be a minus iota b. For example, if one of the roots is minus 3 minus 6 iota, then just change the sign of imaginary part. So the next root, the second root will definitely be minus 3 plus 6 iota. All right. So if one of the roots is minus 3 minus 6 iota, the other root will always be minus 3 plus 6 iota. Now, since they will always occur in pair, then I can say that if I'm talking about the complex roots of any equation, then they will always be even in number. Either the equation will not have any complex root, or it will have 2 complex roots, 4 complex roots, 6 complex roots, 8 complex roots, and so on. Okay, the number of complex roots will never be an odd number. हमेशा एक even number of complex roots होंगे, कभी भी odd number of complex roots नहीं होंगे. All right, so this is one thing that you have to make a point. Okay, so thus the number of complex roots will either be, like I said, 0, 2, 4, 6, 8, 10, 12, and so on. All right, so this was one thing about the number of complex roots. Right, now let's move ahead and talk about the number of positive real roots. Now you might not be able to understand with this explanation, but as soon as I'll take an example, you will definitely be able to understand. Okay, so please don't worry about this definition. The ultimate thing is the practical point. Okay, so number of positive real roots, if the sign changes k number of times in the equation fx. So let me write any equation as, let's say, x cube plus 3x square minus 4x minus 6 equal to 0. Okay, now in this case, just check how many times the sign is changing. Okay, how many times the sign is changing. So for the first term, the sign is positive, second term sign is positive, third term sign is negative, and fourth term sign is again negative. So the sign is changing only once in this case. Okay, so the number of sign changes in the expression of fx will give you the maximum number of positive real roots. Okay, now since in this case the sign change has happened only once, okay, so this equation can have a maximum of 1 positive real root. Don't worry, I'll definitely take more examples. Okay, so I've just read up till this point. Don't look at the next line. Okay, so let's take one more example. Fx is equal to x raised to the power 4 minus 6x cube plus 4x square minus 2x minus 3 equal to 0. Okay, now let's talk about the number of sign changes very quickly. Positive, negative, positive, negative, and negative. So sign changes are happening how many times? 1, 2, and 3. So this equation will have maximum 3 positive real roots. Okay, मैक्सिमम 3 रूट्स इसके पॉजिटिव रियल रूट हो सकते हैं, उससे ऊपर नहीं होंगे. ओके, फाइन. नाउ I've used the term maximum number of positive real roots will be 3 in this case. Okay, now the other possibilities can be, so if the sign change is k times, then it will have a maximum of k number of positive real roots, or it may have k minus 2 positive real roots or k minus 4. So it will always decrease by even number. Okay, it will always decrease by even number. You may cite the reason for that. Since complex roots always occurred in pairs, तो यहां से अगर कम होगा तो वो complex root में ही जाएगा. Alright, so they will decrease by 2. So in the second example that I have taken, this equation can have maximum 3 positive real roots. Okay, or I can say that this equation may either have 3 or 1 पॉजिटिव रियल रूट. ओके, या तो 3 पॉजिटिव रियल रूट हो सकते हैं या फिर 1 पॉजिटिव रियल रूट हो सकता है. ऑलराइट, 3 से कम 2 पॉजिटिव रियल रूट्स कैन नॉट बी पॉसिबल फॉर दिस पर्टिकुलर केस. Am I clear to each and every one of you? Okay, now next is, so this was number of positive real roots. Okay, now let's talk about number of negative real roots as well. Now for number of negative real roots, what we'll do is So I'm again taking the second example only. So fx is given to us. To find out the number of negative real roots, we will calculate f of minus x. Alright. So Chandan, I'll quickly repeat this one. Now number of sign changes in the expression f of x. Number of sign changes were 3. So 3 will be the maximum number of positive real roots. This is one point. Then what can be the other possibilities? So this number will keep on decreasing by 2. So either this equation will have 3 positive real roots or it will have 1 positive real root. इन दोनों में से एक ना एक possibility होगी. So either it will have 3 positive real roots or it will have 1 positive real root. Alright. Now talking about the number of negative real roots. So what we'll do is we'll calculate f of minus x using the above expression. So f of minus x कितना हो जाएगा? It will be x raised to the power 4. So basically you have to substitute. So basically you'll have to substitute minus x instead of x. So Krupa, wait for few minutes. Okay, I'll take another example and you will get a better understanding for that. Okay, don't worry, I'm not leaving you like this. Please don't worry. So I'm calculating f of minus x. So f of minus x is x raised to the power 4 minus minus plus 6x cube plus 4x square plus 2x minus 3. Alright, now this is the value of f of minus x. Now let's look at the number of sign changes. So here I have only one sign change. So maximum number of negative real roots will be 1. Maximum number of negative real roots will be 1. Okay, so this equation will definitely have one negative real root. Alright, so there were 4 roots. So one negative real root, and for positive real roots, it may be either 3 or 1. Okay, now let us understand one more thing. So let's make a table for this. Okay, and let's write down whatever we have done. Okay. Now, I'll make different columns. So first of all, for complex roots, then for positive real roots, and for negative real roots. Okay. Now, number of negative real roots will always be 1. So if number of negative real roots will be 1, okay, then number of positive real roots can be either 3 or 1. So if I'll take number of positive real roots as 1, then what will be the number of complex roots? Number of complex roots will be 2. The another case, number of negative real roots agar 1 lete hain and number of positive real roots, I'll take it as 3. So number of complex roots will become 0 because this equation will have a total of 4 roots. Alright, so this is how we can get an idea about complex, positive real and negative real roots. Now let's look at the question. Okay, so Joydeep, you are asking positive real root is equal to change of sign. Now Joydeep, number of positive real roots will be equal to the number of sign changes in the fx, and that will be the maximum value which will keep on decreasing by 2. Okay. Similarly, number of negative real roots will be the number of sign changes. The number of sign changes in f of minus x. Okay, am I clear? So I will just show you the slide and will take an example separately. All right, so I'll take few more examples separately and will tell you. Chandan, don't worry, I'll take an example. Okay. Okay, so number of positive real roots, if the sign changes k times in the equation f of x, then the equation will have a maximum of k number of positive real roots. The other possibilities can be k, k minus 2, k minus 4 and so on. Talking about the number of negative real roots, the sign changes in f of x, let's say it is m. So m times the sign changes in f of minus x. So the equation will have a maximum of m number of negative real roots, or the other possibilities can be m, m minus 2, m minus 4, and so on. Let's take an example for this to elaborate this complete fact. Now all of you focus on this example. F of x is x cube minus 2x square plus 4x minus 5 equal to 0. Okay, I will fill the values in this table for all of you. Okay, now first of all of you will have to tell me what is the number of sign changes in fx. What is the number of times the sign has changed in f of x? Come on. All right, now Vicky, it is 3 times, not 4 times. So positive, negative, positive, negative. So number of sign changes 1, 2, and 3. Okay, so I can say that this equation will have a maximum of 3 positive real roots. All right, this is the first thing. Maximum 3 positive real roots. Okay, so अगर maximum 3 positive real roots हो सकते हैं, so what can be the possibilities? So this equation may have 3 real roots, or what will be the other possibility? What can be the number of positive real roots? It can be 3 minus 2, that is 1. Now, if I talk about the total number of roots, since this is a cubic equation, the total number of roots for this equation will be 3. All right. So if number of positive real roots are 3, then the number of negative real roots will be 0, and the number of complex roots will also be 0. Okay? But I'm not filling this value right now. Fine? Okay. Now let's talk about f of minus x. So f of minus x, I'm writing it. So it will be minus x cube plus, sorry, it will be a negative sign again. So minus x cube minus 2x square minus 4x minus 5. All right. Am I clear? Have I written it properly? Yes or no? So what is the number of sign changes in f of minus x? What is the number of sign changes in f of minus x? Come on. So number of sign changes in f of minus x is 0. So this equation will have maximum 0 negative real roots. All right. So number of negative real roots will definitely be 0. Now tell me, total roots are 3. If the number of positive real roots are 3 and number of negative real roots are 0, so what will be the number of complex roots? What will be the number of complex roots? Now the number of complex roots will definitely be 0. Exactly. Good. Now next thing, if the total number of roots is 3 and number of positive real roots is 1 and negative real roots are 0, so what will be the number of complex roots for this particular case? Exactly. Good. So number of complex roots will be equal to 2. Okay. So this will be the possibility of the nature of roots of this equation. So this equation will either have all positive real roots, or this equation will have one positive real root and two complex roots. Am I clear with this? Yes or no? All right, friends. So that's all from my side for the day. Please, all of you, if you like this session, it's a request, please do press a like button. Also, please leave some comments in the comment section as soon as this session is over. So please, instead of just writing something in chat box, please do leave something in comments. All right. And share this session and do subscribe our channel. All right. Now, friends, this is as usual the schedule that we follow for the entire week. Okay, so you may take it down. Also, All free lectures at one place you can access. Just look at the link in the description. Okay, so check for complete free classes at one place. This is the information about one of the batches that we are offering at BYJU'S Exam Prep. So this is for the students who are preparing for examinations like SNAP, NARSI Munji, CMET and TISNET. Okay, so you may also enroll for this batch and the complete details are mentioned. Now friends, we are coming up with All India Open Mega Mock Challenge for CAT 2021, which is going to be live on 28th of September till 4th of October. So please do participate. Joydeep will have our next class tomorrow. Okay, so tomorrow I'll be starting with functions. All right, so I believe one of the favorite topics of yours. So yes, Chandan, we are taking a simple logic. Okay. All right. So these are different courses for CAT as well as other MBA examinations that we offer here at BYJU'S Exam Prep. Different online classroom programs. CAT 21 percentile booster course and CAT 22 a complete course. The complete details are mentioned on your screen. The list of experts that we have on our panel. Thank you, my dear friends. Please follow us on Instagram, Facebook, join us on Telegram, and do subscribe this channel. Thank you very much. All the